Assalamu alaikum students. I'm your maths teacher, Miss Aisha Haroon. Today we are going to learn about the surface area and volume of a cuboid in chapter 12, three-dimensional solids. Let's recall the concept of cuboid. A cuboid is a three-dimensional solid formed by 6 identical rectangular surfaces. It has 6 surfaces, 12 edges, and 8 vertices. Please look at this rectangle, which is a two-dimensional figure. But when such 6 identical rectangular surfaces combine together, they form a cuboid, which is a three-dimensional solid. Now, the area of a rectangle. Let's understand the term area. Area is the amount of surface covered by a 2D shape. Now please have a look at the rectangle along with its two dimensions. One is length and the other one is breadth. So how can we find out the area of a rectangle? By taking the product of these two dimensions. So the area of a rectangle is equals to length multiplied by breadth. And remember that in a rectangle, length and breadth are two different dimensions. They are different in measurement. They are unequal. So the area of a rectangle is equals to L multiplied by B. We can write it like this because L represents the length of a rectangle and B represents the breadth of a rectangle. Surface area of a cuboid. Surface area and area are the two terms which mean the same, but we use the term area for a 2D figure, whereas surface area is the term which is used for a three-dimensional shape. So for a cuboid, we are using the term surface area. So the surface area is the amount of surface covered by a 3D shape. And here we can see a cuboid along with its three dimensions: length, breadth, and height. And in a cuboid, we know that these three dimensions are different in measurement. That is, length, breadth, and height are unequal. So how can we find out the surface area of a cuboid? Surface area of a cuboid is the sum of the area of its surfaces, which means that we can easily find out the surface area of a cuboid by adding the area of all of its 6 surfaces. Now we are going to find out the surface area of a cuboid by adding the area of all of its 6 surfaces. Please look at the cuboid. Now let's label its 3 dimensions. length, breadth, and height. We can label the similar dimensions like this: length, and this is breadth, and this one is height. It doesn't make any difference, but we are doing it just for our ease. So now, let's focus on the upper surface of a cuboid. Now, if we are supposed to find out the area, of course, we are going to take the product of two dimensions of the upper surface of a cuboid. So, area of surface 1, which is the upper one, can be written as length multiplied by breadth, because the upper surface is having only two dimensions, which are length and breadth. Now let's focus on the second surface, which is the lower one. And the lower surface is also having only two dimensions, length and breadth. So area of surface 2 is equals to length multiplied by breadth. Now please focus on surface 3, which is the rightmost. And it is having two dimensions, which are breadth and height. So the area of surface 3 is equals to breadth multiplied by height. Now the surface 4, which is the leftmost surface of a cuboid. It is also having only two dimensions, which are breadth and height. So the area of fourth surface is equals to breadth multiplied by height. Now please focus on surface 5, which is the rear one or the back one. So area of surface 5 is equals to length multiplied by height, because that surface is having the two dimensions, which are length and height. Now please focus on the front surface of a cuboid, which is sixth surface. So the area of surface 6 is equals to length multiplied by height. As we have already taken out the area of all of the 6 surfaces of a cuboid, so now we are going to add them up to get the surface area of a cuboid. So the area for the first surface, it will be added to the area of the second, then third, fourth, and fifth, and the last one, the sixth surface. So now we are going to add up the area of all of the 6 surfaces of a cuboid to get the surface area of a cuboid. As we can see that in this equation, we are having the product of length and breadth 2 times. It is getting added twice. It is written twice. So we can write it down like this, as 1 plus 1 is 2. So of course we can write it like this, that 2 multiplied by length multiplied by breadth, or we can say twice the product of length and breadth. In the same way, we can see that in the above equation, breadth multiplied by height is written twice. So we can add them like this: 2 multiplied by breadth multiplied by height, and again in the same way, the product of length and height are written twice, so we can write them like this. So in all of these 3 terms, we can see 2 is the number which is common. So we can take 2 common and write all of these terms within the square bracket. So, what is the surface area of a cuboid? Yes, the surface area of a cuboid is equals to twice the sum of length multiplied by breadth plus breadth multiplied by height plus length multiplied by height. Volume of a cuboid. Now what is the term volume means? Volume is the amount of space occupied by a 3D shape. So the volume is actually the space which is there within a 3D shape. So volume of a cuboid is actually the amount of space which is there within the cuboid. So how can we find out the volume of a cuboid? As area of a figure is the product of its two dimensions, in the same way, volume of a 3D shape is actually the product of its three dimensions. Or we can simply write down the formula like this, that volume of a cuboid is equals to area of a base multiplied by height. And area of a base refers to the area of one of the surfaces of a cuboid. So which means that we are supposed to write down the area of one of the rectangular surfaces which are there within a cuboid. And what was the area of a rectangle? Yes, it was length multiplied by breadth. But here volume of a cuboid is equals to area of a base multiplied by height. So now the volume of a cuboid will become length multiplied by breadth multiplied by height. So this is actually the volume of a cuboid.